Hey guys, welcome back to the channel. In this video, I'll be covering some common examples of solving equations of one step that you will encounter in your math classes and your studies through your journey to calculus and even further. So before we hop into the meat of the video, please hit that thumbs up button and subscribe to the channel for more content. So before we can even, so let's just hop right into it. So before we can even start solving equations, we need to define a basic rule of algebra that we use all the time. All right, so, and what that rule says it's whatever you do to one side of an equation, you must do to another. All right, so we use that a lot in physical sciences, like in physics, when we're trying to solve for velocity or acceleration, or anything really in physics. When we're trying to balance chemical reactions, we do the same thing. Similarly, what else? Oh, also in mathematics, in later mathematics, especially in calculus 1 and calculus 2, when you're trying to solve, do integration by parts and use substitution. So pretty much what we're doing is we're trying to isolate a variable. That's the whole goal, is isolate one variable. Leading up to this point, you guys were doing the basics of basic simplifications using the order of operations. Now we're trying to undo that to get one variable, one term with the variable on one side, and solve the equation, and pretty much isolating the variable. Kind of hard to explain for me, but it's best if I show you guys. So let's start with our first example. Okay. So this will be adding one. So we use our 4 basic operations to make sure we isolate the variables. It gets more complex as the further we go into algebra, but so for now, let's just start with the basics. So we have x. Sorry about that. So let's say x plus 9 is equal to 3. Sorry, I'll fix that. 9 is equal to 3. Okay, so all right. So the whole goal is to get x by itself. Okay, so the whole goal is to get x by itself, and so to do that, we must get rid of we must move this 9 to the other side. To do so, though, we need to undo this addition. So we subtract 9 from both sides. And the reason why we subtract 9 from both sides, not just from one, is because of the rule we just mentioned. What you do to one side, you must do to another. So x is equal to, so 3 minus 9 is negative 6. The 9's cancel out on this side. So the x comes down, and the equal comes down. So that's negative 6. Okay, speed that up. Okay, so B. So let's do another example. So x minus 5 is equal to 10. Okay, so now similar case. It's a single variable. So pretty much, but we have a minus. We're trying to get this variable by itself, but there's a subtraction, a minus 5. And we want to move this minus 5 to this side. So we want to move this 5 to this side. And the only way we could do that is by adding. So we add 5 to both sides. X is equal to 15. So the 5's cancel out. Minus 5 and plus 5. The x and the equals come down. And 10 plus 5 is 15. Okay. So that's addition and subtraction. So what if we have a multiplication? Okay. Okay, so say we have alright, so let's say we have alright, so another example, C. X over 3 is equal to 6, okay? Well, x over 3 is a division statement. It's a fraction, so we're dividing. We're dividing 3 into x. And so to undo a multiplication or a division, we multiply by the reciprocal. Okay, so we're going to multiply both sides by 3. So x is equal to 18. Okay, let me zoom that in for you a little bit. Oops. All right. Move my camera just so it's... so x is equal to 18. Okay. Or what if we have a full fraction? 3/5 x is equal to x. So we do pretty much the same thing. So we have 3/5 times x. Oh, sorry. Is equal to, let's say, 2. All right. So like this example, we are going to multiply by the reciprocal. So the reciprocal is just the flipped. We just flip this 3/5. So we flip this. And we have 5 over 3x. 5 over 3 times 3 over 5. X is equal to 2 times 5 over 3. Zoom that out a little bit for you guys. There you go. So by multiplying fractions, reciprocal times so two reciprocals multiplying each other comes out to be 1. So that's 1x is equal to 2 times 5/3, and so we multiply the numerators. So 2 times 5 is 10. So it leaves us 10/3. 1x is equal to x. So x is equal to 10/3. Okay. So also just notes. This is a special case. So this is a special case. So we call this is a special proportion. We could have easily just cross multiplied to solve the proportion, and we'll go over that some other time. But let's finish off the examples with dividing. So say we have 3x is equal to 9. Okay. All right. So what the statement is saying is 3 times a number is equal to 9. Well, what is that number? Well, similar is so like we did with the multiplication, we undid the division by multiplying. Well, we could undo the multiplication with division by dividing 3 to both sides. Okay, so the 3's become 1 because the number divided by itself is 1, and it leaves us with 1x is equal to 9/3. Well, that simplifies out to x is equal to 3. Okay. Last one. All right, so we have 9x is equal to 1/3. Just like the previous example, we're going to divide it by 9 on both sides to isolate the variable. So divided by 9 is the same as multiplying by 1/9, and that's by the multiplicative inverse that we covered in the properties of arithmetic. So this cancels out to be 1. So we have 1x is equal to 1/3 times 1/9. So basic multiplying fractions. X is equal to 1 on the top, 27 on the bottom. 1/27 is your total. All right, so just a quick recap. So just to solve the equations in one step, we pretty much undo any operations to isolate our variables. So it could be y, it could be any variable. Just since I conventionally use x, and a lot of books conventionally use x, especially when you guys are solving for critical numbers and stuff, it comes really easy. It's easier to show you in this sense. So whether it's addition, and so if we have addition, we undo it with subtraction. If we have subtraction, we undo it with addition. And if we have multiplication, like in earlier examples, we undo it with division. And vice versa. If we have multiplication, we undo it with multiplication. I'll see you guys next video.